In this video, we're going to talk through the worked out solutions to this Unit 7F review, story problems. So the first problem is talking about throwing a penny off of a building. And we have the equation that models the height t seconds after it's been released. So the first question is, what is the height of the building? Well, the height of the building, I have to think through when am I at the building. I'm going to be at the building at the very beginning when I drop the penny. So the height of the building, that's when t is equal to 0. So I'm really finding h of 0. So I can substitute in 0 for t. And when I do that, if I simplify this using order of operations, I will see that this ends up being 1,482.6. And we need to make sure we have units. So the height is in meters, so it'll be this many meters. So that is the height of the building. In other words, it is where our y-intercept is. Alright, looking over here, after 3 seconds later, what is the height of the penny off the ground? Well, it's telling us what the time is. That's time equals 3. So this time we're finding h of 3. And we just substitute in. You've got to remember to do order of operations, exponents first, and then our multiplication, and then the addition. And when we do that, we get that that is equal to 1,438.5 meters. And here, when does the penny hit the ground? Well, when it hits the ground, that's when the height is 0. Or in other words, we are finding the x-intercept. So that's going to be when we substitute 0 in for h of t, negative 4.9 t squared plus 148.6. And now I just need to solve the equation for t. When I look at this, the equation is in vertex form. I only have a t squared, no other t's anywhere, so I'm going to solve using inverse operations. I want to isolate what's being squared. Now I've isolated what's being squared. This is 302.57. So now I take the square root. I get that t is approximately plus or minus 17.39. Remember, as soon as we take the square root, we've got to put that plus or minus in. However, it doesn't make sense for time to be negative in this situation, so we'll just say time is approximately 17.39 seconds because this units are in seconds. Switching over here, what time is the penny at a height of 500 feet? So now we have 500 is our height, equals negative 4.9 t squared. And again, because this is in vertex form, we're going to solve this using inverse operations. So we get negative 982.6 equals negative 4.9 t squared. Divide by negative 4.9 again so that we isolate that t squared. We get that this is approximately about 200.53. We take the square root to undo the squaring, and we're left with t is approximately plus or minus 14.16 seconds. But again, because the negative time doesn't make sense in this situation, we just have our positive answer. Moving on to the next one, number 2. You're kicking a ball from the ground with an initial velocity of 80. As the ball moves upward, gravity slows it. Eventually, the ball begins to fall back to the ground. Okay, so let's kind of look at a picture here. We're starting on the ground, kick it up, hits the ground again. All right, so we know we're going to start at the origin, and we're going to land somewhere over here, and at some point we reach a maximum point at the top. All right, now it says write an equation that models the height of the ball after t seconds in the air. Okay, and it tells us to refer to our notes. We need to remember that this equation would be h of t is equal to negative 16t squared plus the initial velocity times t plus the initial height, h sub 0. We just have to substitute in. So the height, h of t, will be equal to negative 16t squared. The initial velocity was 80 feet per second, and the initial height was 0, so we could write plus 0 if we wanted, but really how we should write our final answer is just negative 16t squared plus 80t. That would be our final answer because we don't need to write the plus 0. Now the question is, for how many seconds is the ball in the air? Well, it's going to be in the air from the beginning all the way till it hits the ground. So we really want this other x-intercept. And we're going to get that when we realize that the height is 0. So h of t equals 0 at that point. So 0 equals negative 16t squared plus 80t. And now I'm going to solve this equation. I have a t squared and a t, which is telling me it's standard form. So when I have an equation in standard form, what I'm going to try and do first is solve by factoring. And I know that my first step in factoring is to factor out the GCF. When I look at these two terms, I know that the GCF of negative 16 and 80 is negative 16. Again, I'm factoring out a negative because the leading coefficient is negative. And because this term has a t squared and this term has a t, I can factor out a t from both of these as well. Negative 16t times t will give me negative 16t squared. Negative 16t times a negative 5 will give me the 80t. Now when I look inside here, I see that I have a linear factor. There's nothing being squared, so I've factored it as completely as I can. And now I use the zero product property. I set negative 16t equal to 0 and t minus 5 equal to 0. And when I divide both sides by negative 16, I get t equals 0. Add 5 to both sides, I get t equals 5. Now the t equals 0 is the starting point. We already knew that one. So how long is it in the air? Well, it lands after 5 seconds, so 5 seconds. There we go. Next question is, when does the ball reach its maximum height? And that word maximum should make me realize right away that we're finding the vertex. Now let's take a look. We already know the two x-intercepts, 0, 0, and 5, 0, which I know the axis of symmetry is right smack dab in the middle. So my axis of symmetry would be x equals 2.5. Or really, I guess I should say t equals 2.5. So when the time is 2.5 seconds, that's where we're going to reach the maximum. So to figure out what the maximum is, I could substitute that in. But you know what? It's just asking me when does it reach it. So that's all I have to find out. After 2.5 seconds. Now part D asks me what is the maximum height, so now I have to substitute that in, h of 2.5, and I just substitute that in for t. Again, we want to make sure we're using order of operations to simplify this, and when we do that, we square that first as negative 16, 2.5 squared, what do we get? What was that, 6.25? Now I can do multiplication. I get negative 100 plus 200, which gives me a positive 100. So its maximum height is 100 feet. It's the highest it'll reach. All right, flip into the back. Number 3, we're given another equation. So the duck dives under the water, and its path is described by this quadratic function. So if we're looking at, you got your water here, you start the duck here, it goes under the water and comes back up. So there we go. X represents the time in seconds, and we have this equation. How long was the duck under the water? Well, let's think about this. We have to look at our x-intercepts for that. Well, the x-intercepts, if I have my equation, is when y equals 0. Well, this is already in intercept form, so I can use the zero product property to solve. I get x equals 0 and x equals 2. That means it starts at 0, 0. It comes back up to the top of the water at 2, 0. So it is after, how long is the duck underwater? For 2. And it says time is in seconds, for 2 seconds. How far under the water did the duck dive? Well, that's this length. How far under? So we're going to be looking at that vertex again, and we want the y coordinate. So we know it's after 1 second. That's our axis of symmetry. So now we just substitute 1 in. So 2 times 1, 1 minus 2. So we have 2 times negative 1, or negative 2. So the question would be, why is this negative? Well, the reason it's negative is that we're going below water. So this is 2 meters below. All right, next question. When was the duck at a depth of 5 meters? Well, it's at a depth of 5 meters when the height, y, is negative 5. We can do this a couple different ways. One way to do it is to look at the graph. If we know it only went down 2 meters, it can't possibly go below that, so it will never reach that depth. Or you could substitute negative 5 into the equation. this one's a little trickier. In order to solve this problem, I'm going to actually have to distribute because it's not equal to 0. So negative 5 equals 2x squared minus 4x. Now that I have it written in standard form, I can add 5 to both sides, and I can solve this using the quadratic formula, or by factoring. If I try to solve by factoring, it's not factorable. So quadratic formula says x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And when I simplify this discriminant, I can type that entire thing in my calculator. I get negative 4 squared minus 4 times 2 times 5, a negative 24. Well, when the discriminant's negative, I know that there is no real solution. Which means there is no time x for which the y value, or the height, is negative 5. And then finally, how long was the duck at least 0.5 meters below the water's surface? Well, that would be, to be at least that would mean we're down here. So all this time, so from here to here. So we got to find the x values that go from here to here. That means we have a negative 0.5 equals 2x times x minus 2. Again, I'm going to solve this just like I did the previous one. 2x squared minus 4x. I'll add the 0.5 to both sides. And I can use the quadratic formula again. Now before I do, I want to get rid of the decimal. Because it's 0.5, if I multiply everything by 2, it'll give me an equation that doesn't have a decimal. So I'm going to multiply everything in this whole equation by 2. So it'll become 2 times 0 is 0. We got 4x squared, 8x, plus 1. And now when I use the quadratic formula, I get the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. X equals 8 plus or minus the square root of 48 all over 8. And if I do the approximate solutions, I end up getting that x is approximately 1.866 and approximately 0.133. That means this first one, after 0.133 seconds, it hits that depth, it's under, and then it reaches that depth again at 1.866 seconds. So, to be at least that far, we got to be from here to here. Or if I subtract these two, it'll give me the total time that it was under water. Oh, sorry, not underwater, under 0.5 meters below the water surface. So that would be 1.73 seconds. Alright, so that's our quadratic story problems. If we look here, here's some final exam review. Looking at this one, because it's a V-shaped graph, I know that's absolute value. And remember, absolute value, that equation is going to be y equals a times x minus h plus k. The a value we get by using the slope. So here we go, down 3, right 3, so negative 3 over 3, or negative 1. Here we go, up 3, right 3, 3 over 3 equals 1. So our a value is just going to be 1 because this is opening up. I'm not going to write the 1 because we don't really need it. I noticed that the vertex was translated to the right 3, so to do that we have minus 3. And then we don't have to add anything at the end or subtract anything because we're not translating up or down. The domain are all the possible x values. That will be all real numbers because the graph doesn't stop going to the left or right. The range are the y values. When I look at this, the lowest y value is 0 at the vertex. And the highest y value, well, this goes up forever, so it's y is greater than or equal to 0. Excursion over here, because this shape is a U-shaped graph, that's a parabola. The family is quadratic. Axis of symmetry, I know that goes smack dab down the middle, so that'll be x equals 2.5. My domain is all real numbers. The range, if we look at that, looks like that's y is less than or equal to 3.25. The highest y value, that's 2.5, comma 3.25, then it's everything below there. Then finally here we need to look at the pattern. So if I look at this, I say I multiply by 2 again, and so on. So as x increases by 1 each time, the y is getting multiplied by 2. That tells me this is an exponential function. And I remember that exponential functions are written in the form y equals a times b to the x, where a is the y-intercept and b is the common ratio. The y-intercept is when x is 0, so I got to go work backwards. Subtract 1, divide by 2, so I'll have y equals 3 times the common ratio is what I multiply by each time, and there's my equation. Then finally, splitting down here, properties of exponents. I can do this a couple different ways. First, multiply 7 times 2 is 14. X squared times x to the third times x to the 0. Well, x squared is x times x. X to the third is 3 x's. X to the 0, I remember that anything to the 0 power is just 1. So I'm just going to multiply that by 1. That gives me 14x to the 1, 2, 3, 4, 5th power. You could also remember that when you multiply two powers with the same base, you can add those exponents. Scooting over to number 5, I look at this and I see the negative exponents. I know I cannot have negative exponents as my answer. So I'm going to circle what's being raised to the negative exponent. This 9, because there's no parentheses, is not being raised to the negative exponent, so that's going to stay right there. The other guys are going to move to the numerator and become positive. And there's my final answer. And then finally down here, I can do this a couple different ways. I like to simplify inside the parentheses first. Again, I have that negative exponent that I don't like, so I'm going to move that up there. I get y to the 4th times x to the 1st, and then because it's x to the 1st, I'm not going to bother writing it, and then that 5 stays in the denominator. I still have to square that, and when I squared, I realized I have to square everything inside here. So x squared times y to the 4th squared is y to the 8th, divided by 5 squared is 25. And there's my final answer. And that is our review for the story problems of quadratics.